Today is November 17th and I've made this so far. I made some upgrades. It's still prototype, but I made some upgrades to the ring sucker. So this thing I upgraded to this, and it's very, very good because you can just put it there and then oh my gosh, bro. Right now this is a good one. And it just drops it on there. Alright, it's like this. Let's see right here. The point in which the ring sucker prongs come in is approximately like, see right there. Kind of knocked it off balance, but pick it back up and sure, little. And that's how I got it. Now this is like the. I guess I'm testing two. I'm testing this design right here and this weird ass design right here. Look at this, like this. This weird design right here. I don't know what it is, but that's just how it is. And this one it allows it to just be on there, and then this part, this smiley face part, grabs it, and it releases at the point of this shorter side. So when it goes up, as you can see, it's right there. And then when it's right there, see that? The smiley face, pretty much. The smile part of the thing is very good to get it. And then the other side just is good for dropping. And then this is just the universal one right here. It pretty much is just even. And I don't like it because it just does that. So I think this is more. And this one, let's test this one. This one also does it. Oh, it's just like, there's a problem with it. Like, sometimes it works and sometimes it doesn't, but look. I think the way it works is that it has to be like this. Centered like this. To get the maximum grippage. So we see right here. Boom, easy. But if we retest it and turn it this way, where it's the flat side, or the flatter side, then let's go over here. It just hits that. And let's try it with the other one as well. And what happens? Let's see. Yeah, I think it has to always be like this. Yeah, pretty much. And if it doesn't do that, it could just actually do reverse. Look. You need to position it correctly and it can do reverse and just go like this. And then boom. And another thing I'm worried is that I haven't tested it with a goal yet. Since we're going to have a mobile goal to put it over here. I haven't tested it with the goal yet. And I kind of really want to test it with the goal right now. But I don't have it right now since I'm at my house. And that thing, I just don't know the positioning of the goal yet. And that's a worry for me. But as long as this thing can just do this, for autonomous at least, just use it for that, then that would be good. And I think that's going to be the biggest problem. Without the goal, you can't really measure anything, you know. You can't really measure how much velocity or torque is going to be too much or be too little. If it's the mobile ring, it's just super light. And most of the times before I tested it in the first design, the mobile goal was never positioned good, or this thing wasn't positioned good, because if you think about it, the biggest thing is that we had to conserve a lot of space, because this is how much space we had. We had only, I'd say, a license plate, nearly like a license plate of space to work with. Because look, our lift collapses. Our lift collapses, and due to that, oh yeah, and another issue, bro, watching Black Clover. All right, and another issue is that this thing has to be like this, at a 90-degree angle or above, to always actually work. Because if it doesn't, if it's closed all the way, you're gonna see the problems there, right? It has to be like this. So that's another issue, but I wouldn't see that as much of an issue since I just really want to use this for autonomous and that alone. But if we do use it in game, then that would be an issue since we couldn't really do it, pick up rings and do the goal at the same time. But, you know, This would probably be more useful as a preload, not to pick up rings on the field, as more as a preload. Preload rings, that would be much a safer option, since we have to position the rings correctly, like this, to get the maximum grippage. And then this is like universal ring sucker here. Just put it there, and then this thing just goes in, and it's an almost guaranteed pickup. But if we have it like this on the flatter side, then it's not guaranteed at all. It's just gonna do that, and that's why I really want to emphasize that point right here, that it's almost based off luck. But the preloads is guaranteed. The preload is guaranteed since the person's gonna be placing it. But during the match, if we ever want to do pickup rings and it ends up like this when we're going for it, if it ends up mispositioned at all, then we're not gonna be able to do anything, and that's over for us. And the lift, I don't really want to focus too much on the lift since I pretty much already built it, but that's the lift. And I also added these things, which is pretty easy since our shaft kept bending. The goal kept on bending the shaft for some reason, and that thing messed it up. And these things, I hope they're useful to help us park. I don't really want to explain that, but as you can clearly tell, there's legitimately nothing over here to counterbalance. This thing is very forward balanced. The whole lift is just very badly balanced throughout the whole robot. Like, this whole thing is heavy. And adding this as well, and that brings me on to another point. I also added this anti-tip. These little wheels, they actually do touch the ground sometimes. But I might add some rubber or something to make it touch the ground at all times, because these little wheels might help us back up the platform. Along with these, that's what I'm hoping for. These anti-wheels do work, and I need to cut it right here because the shaft is going to be way too long. And like, we're almost already 18 when we get here, and that's a problem. And you always have to have it like this. And another thing, you always have to have the thing like this, the rollers, because then this part is going to touch this. And the way the robot works is that it picks up mobile goals by using this as an elevation platform right here. The mobile goal, the outside part of the mobile goal just stands on here, while this claw clamps down, grabs it tight, and picks it up, and we can score goals like that. And then the lift is pretty simple design, of 4-bar, since you don't really need to elevate as much. The platform where you need to park it on is not as high as like Tower Takeover or anything, with the ginormous towers that were super tall. And you got support here. And I made this design, but mostly we made a Moby robot design. We pretty much stole the blueprints from Moby and applied it to our robot. And we only have one motor drive due to that. And that's another big problem, that the one motor drive or the two motors, is not good at all. It just has no power whatsoever compared to a 4-motor drive. Because we had to sacrifice 2 motors for the Moby. And it ended up being an uneven amount of motors, since we had 2 for Moby and 2 for the lift, 2 for Moby, 2 for the lift, 2 for the wheels, 1, 2, 3, 4, 5, 6, and 7. 7 is being the claw, and 8 over here. 8. And they're all green motors, so we don't have any power motors because our school doesn't have it yet. And that's the problem. I like to use the red motors for torque, but I couldn't use them at this situation, so we had to be conservative with the power, and that's why I went with the 12 to 84 tooth gear. Calculate the gear ratio yourself. I don't really want to, but that is pure power. This is actual pure power right here, just because of the gear itself. And then these rubber bands are very useful as well because they help the robot go up faster, you know, like this. Stands, look at that. It doesn't even go down or nothing, it just goes up. And yeah, that's pretty much the whole robot. The wheels here, over there. There's no motor on the wheels over there. The brain is kind of crappily placed, but that's like all the space we have. We have nothing. We have nothing at all. And I like this motor cartilage because I got an advice from someone in the competition to add gears to spin this instead of just being the shaft, because it just used to be the motor connected to the shaft, and that's why the shaft would bend, because it had no power, no torque, and then the mobile goal just clamping it would just bend it. And then this claw now is just very, very powerful. I could barely, like, it takes a lot of pressure to move it. It's easier to move the lift up than it is to do that. And yeah, that's pretty much it on the robot. See you.